So in the last video, despite many dramas, we finally finished the sliding cart. And now I have the choice of whether to build a base first or to build the top first. Now the top has some pretty difficult off-centered turning that has to be done on a metal lathe. And I'm going to leave that to the last because I've currently had enough with turning. But thank you guys for the advice about metal turning from the last video. Very helpful. That means we'll be building the base first, which will also allow me to actually test out the sliding cart.
The majority of the parts are MDF. This is because when it is properly sealed and under normal room conditions, it is very stable. However, it is quite flexible and weak, so the structural features of the sliding table has been designed to overcome these weaknesses. One is having the base constructed similarly to an I-beam. Hence I needed to cut some dados, and I am using the perfect dado trick introduced to me by Matthias Wandel.
Working our way from the bottom, we have a few holes to drill in some metal and a slot to cut out here to allow the bolt, and more holes to drill on the MDF. This metal plate basically serves as an anchor point for fine-tuning the sliding table to be in line with the table saw. And this is done by screwing a M6 bolt into the MDF through the metal plate, and by tightening or loosening the bolt, it will move the sliding table accordingly. To make the sliding table able to move past the metal plate, I'm going to make a little cutout over here. But first, I might just drill the hole and tap the hole for this M6 bolt. I might actually just use a T-nut.
I mark the holes out with the grab point bit first, then I use a block of hardwood to guide the drill bit. Then I mark the cutout, which doesn't need to be very accurate, and cut it out on the Bensound. With the base out and about, I might as well drill out the center holes, which is actually a slot. Then by clamping the edge of my vise to prevent splitting, I can drive the threaded insert in.
And so the idea is that the bolt will go through the metal plate like so, and then be screwed into the threaded insert. Then I'll put a lock nut onto here, screwed onto the bolt, so that when I unscrew it, it will carry the carriage as well, instead of just backing out. But as you can see, there aren't any threads on here, so I'll have to extend the threads all the way up there, but not to the very end.
Strangely, even though both ends of the die looked exactly the same, it was easier to cut with one end, so I suppose they do have a specific orientation.
With one side working, it's time to repeat the same thing for the other side. Luckily, I do have a few tricks up my sleeve. Ta-da! Done! And the bolt just basically locks everything down once I have made the adjustment.
Now the vertical adjustment mechanism.
These bolts basically serve as a vertical adjustment for the sliding table, and the top goes on like so through all the holes and bolts, and by turning the nuts underneath I am able to adjust the sliding table up and down accordingly. Now I have to try and secure the thread rods into the holes so that it doesn't turn when I turn the nut. Now that really wouldn't be a problem if I haven't already drilled the holes to be exactly 8mm, which means I can't secure the thread rods by tapping into the hole. So that leaves me with the option of just epoxying them into place. Hopefully it will be strong enough.
Oh yes, almost forgot to tape the bottom.
It's been overnight, so the epoxy should have dried. And by the way, Merry Christmas! Today is Christmas on the time that this is filmed, so Merry Christmas! What a reason. Came out nicely. The tape didn't really stick to the epoxy, so that's good. Since it's Christmas, I can't really use any power tools that make a lot of noise, so I'm going to glue up the bottom half of the I-beam instead. Now for the joints between this small block and the rest of the MDF, it is gluing MDF to a plastic veneer, and that usually doesn't work very well with Type 1 2, so I'm going to have to stick to the usual PVA glue. I'm going to place down the top layer without any glue so that to ensure the dado is still in line after the glue has dried. The next bit is to make the V-groove for the metal rails, and to do that I've already set up my router for it. I've got the fence on the opposing side so that I can fit a spacer in between once I have finished making the first cut, and a spacer would ensure that I get the same distance between the two V-grooves every single time.
Checking that I do indeed have the correct depth before routing all the way. Now attaching the spacer, which has a width equivalent to the distance between the two bearings on the same axle.
Looks pretty good, doesn't seem to have any gaps. So I should be within 0.1 to 0.2 of a millimeter of accuracy, which should be good enough. So I'll keep the same spacer for when I cut the V-grooves on the top half of the sliding table. To mount the rails, I'm going to be drilling through the center and then countersinking the hole, so to fit these M3 bolts, and I'm going to do this by using this specially made V-block that has a 3mm drill down there, so to ensure that the drill bit is nice and straight, and I'll just use a hand drill to drill right through.
I have to remove the guide block at the end because the drill bit isn't quite long enough. I can then drill through partially with a larger drill bit to countersink the head of the bolt.
Now the bolts I'm using for this isn't actually long enough for this application. As you can see, it doesn't even poke out from the other side when I insert it from the top. So instead of making a deeper countersink, I'm going to drill through from the other side and then also press the nut into the MDF.
Then I can hammer the nut into the enlarged hole by threading it onto a bolt.
Seems to work.
Now I can finally glue up the whole I-beam, which I am starting to think is actually called a torsion box. After having it sit in the oven for the afternoon, I can screw on the end caps which prevent the carts from derailing. By the way, my workshop is the oven.
According to the original plans, the base of the sliding table would be called done. But since I'm having it as an external attachment, I have to figure out the part where it actually attaches to the table saw. As you can see, my table saw is actually just a job site table saw, not even a contractor saw by classification. And that's why I have built a very sturdy wooden base for it to sit on, which also extends the range of its fence. and it should provide me with a surface to mount the sliding table on. Now the sliding table measures about 300mm in height, and that comes down to around about here. So that should mean that I'll be able to use these L brackets had left from making the wood racks, and one here, one over there. Just need to find another one of these somewhere in my workshop. They're always just floating around. Now the corner of these L brackets are actually just box jointed together, and apart from Matthias Warnell's experiments on box joints, they have proved to be very strong in the workshop, as I have loaded them with a lot of mass as wood racks in the workshop. Since the length of the sliding table is much longer than the width of my table saw, and that the mounting points for the sliding table must be at these 2 blocks of hardwood at the end of the sliding table for the horizontal adjustment to work, I therefore have to add an extra beam at the bottom of the sliding table.
I am making a dado on the beams because it makes aligning the pieces easier.
Right now it is upside down, but to prevent the MDF from sagging, I'm adding in some more blocks of wood. The important thing to note is that I didn't put any screws between the MDF and the middle pieces of the bottom frame. That is because if I put any screws in it, I won't be able to use a horizontal adjustment, as that would actually just lock it all down. But now, with the middle pieces in there, it prevents sag when I put pressure on top, but still allow the MDF to slide around. Already I can see a potential design problem with the vertical adjustment mechanism here. As you can see, the MDF here, the bottom part, is much thinner than the whole assembly up top. And so when we turn the nut, it might not adjust the top bit, but instead adjust the bottom bit, which we really don't need, since it's this bit that's really crucial to be flat. But hopefully by adding an extra solid wood frame to the bottom, it would add some strength to it. As such, the base of the sliding table is finally done. And once again, it is a combination between metal and MDF. But at least it was much less eventful than when I was building the sliding cart, which is good, because it's not very good for my mental health at all.